Hi dear students, today we will discuss about the topic solution. Okay, so what is solution? Solution is a homogeneous mixture of two or more than two components, means the composition and properties of the components remain uniform throughout the mixture. Again, the component which is present in excess amount is known as solvent, whereas the component which is present in lesser amount is known as solute. So we have two components, one is solvent that is present in higher amount, percentage excess, and another component is solute, less percentage. Okay, so today we will mainly discuss about binary solution, which is a solution where two components are present. Binary solution. Now, if we classify the solution depending on the solvent, solution are of three types: gaseous solution, liquid solution, and solid solution. Solution are of three types depending on the solvent: gaseous solution. So what I told, depending on the solvent. So in gaseous solution, the solvent is gas, means gas is present in excess amount. What about solute? Solute can be gas, liquid, or solid. Similarly, second one is liquid solution. So what our solvent here? Here the solvent is liquid, and the solute similarly gas, liquid, and solid. And third one is solid solution. So in solid solution, solvent is solid, and the solutes are gas, liquid, and solid. So in this chapter we will discuss only about liquid solution. That means our solvent will be liquid, but our solute can be gas, it can be liquid, and it can be solid. So let's first start with gas plus liquid solution. First one is gas plus liquid solution. Okay, dear students, tell me whether gases are dissolved in liquid or not. The answer is yes, gases are dissolved in liquid. And the examples are cold beverage. You have drink Coca-Cola, where carbon dioxide gas is dissolved in sugar solution. So our example is cold beverage. Another example is water, where oxygen molecules is dissolved, and that is most essential for aquatic animals for their survival. Your oxygen molecule is dissolved, your carbon dioxide molecule is dissolved. But our main thing is that we want to know that the solubility of the gas in the liquid, means the gas is how much soluble in water. So we will study about solubility of gas in the liquid. And dear students, the solubility of gas in liquid depends mainly on two factors, where one is temperature and second one is pressure. Temperature and pressure. So first let's see temperature. What happens when we increase the temperature? Solubility decreases because dissolution is an exothermic process. When we increase the temperature, solubility decreases. Okay, and as an example, I can say that you must have seen air bubbles coming out of water when we boil it. And what is the reason behind it? The reason is that when we boil water, that means when we increase the temperature, the oxygen molecules that are dissolved in water comes out as air bubbles. That means when solubility increases, that means when temperature increases, the solubility of oxygen molecules decrease. So this was all about temperature. When temperature increases, solubility decreases. Now let's see about pressure. When pressure increases, solubility also increases. Why? To make you understand, let me draw a diagram. Dear students, see here. What happens when we increase the pressure by compressing the gas to a smaller volume? The density of gas increases, and when density of gas increases, the rate at which these gaseous molecules strike the surface of the liquid to enter into it also increases. So here, since density increases, the rate at which gaseous molecules strike the surface of the liquid to enter into it also increases. And what happens when the rate increases? That means solubility increases. And solubility increases till when? It increases until a dynamic equilibrium is achieved. Okay. And what is dynamic equilibrium? It means the rate of gaseous molecules going out of this solution is same as the rate of gaseous molecules coming into the solution. So finally, when pressure increases, solubility increases. So actually there will be gas molecules that will be soluble here. And high pressure, more number of gas molecules will be soluble. Okay. Now the thing is that a person comes here, Henry. And Henry was the first person to relate the pressure of a gas and solubility of a gas. He was the person to relate pressure with solubility. Let me write here. So, Henry law. According to Henry, the solubility of a gas in a liquid is directly proportional to the pressure of that gas over the liquid. Solubility of a gas in a liquid is directly proportional to pressure of that gas over the liquid. Okay. Now let's do something. Let's replace this solubility with mole fraction. Why we can do this? Because solubility is a concentration term. This is a concentration term which contains moles per volume. So you can see here moles term is coming, and here also mole fraction term is there. So he replaced solubility with mole fraction. So now the law will be mole fraction of a gas in a solution is directly proportional to pressure of the gas in vapor phase. Okay, and this is Henry law. So if we represent it mathematically, suppose let's write this first. Pressure of a gas in vapor phase is directly proportional to mole fraction of the gas in solution, X. Then P will be equal to KH into X, and this is the Henry equation. So from this equation you can see at constant pressure, if KH of a gas is high, this implies that it is constant, and if this is high, so mole fraction should be less. Mole fraction is less, or that is solubility is less. So for a gas having higher KH, its solubility is low. Means if the KH value of a gas is higher, then it is less soluble in a liquid. So this was all about gas plus liquid solution. Okay.